Hello, heterocyclic compounds part 8, and in this part we will see quinoline, that is alpha beta benzopyridine or 1-azanaphthalene, and this is the structure of quinoline. Just draw it as one benzene ring and to it one pyridine ring with alternate double single bonds. This is the structure of quinoline. And the numbering will be like this. Start from nitrogen. 1, 2, 3, 4, 5, 6, 7, 8. This will be 9 and 10. In quinoline, benzene ring is fused with pyridine ring in alpha beta position. So this is alpha position and this one is beta. This is also alpha and beta. So at alpha beta position, ring fusion takes place and we get quinoline. And ring fusion is between the two rings. One ring is benzene ring, this one is benzene ring, and this is pyridine ring. Its nucleus is present in alkaloid synthetic anti-malarials chloroquine, analgesics syncophane, and analytical reagents. And it occurs in coal tar and bone oil. It is obtained by distillation of quinine alkaloid with alkali or base. Hence, it is named as quinoline. Now, let us see the synthesis of quinoline, and this is Skrap's synthesis, very well known and famous reaction known as Skrap's synthesis of quinoline. It is used for preparation of quinoline. And in this process, a mixture of aniline, glycerol, concentrated sulfuric acid, and oxidizing agents such as nitrobenzene and FeSO4 or ferrous sulfate on heating gives quinoline. This reaction is known as Skrap's synthesis. Here, nitrobenzene acts as oxidizing agent as the reaction is exothermic, which tends to be violent. FeSO4 or ferrous sulfate is added to moderate the reaction, and hence this is Skrap synthesis. Let us see step by step. The mechanism of Skrap synthesis involves following steps, and in step 1, the glycerol in presence of sulfuric acid H2SO4 undergoes dehydration, that is removal of H2O, removal of water to form alpha beta unsaturated carbonyl compound, and this is acrylate aldehyde. Actually, the um, structure you can draw like this also, CHCHO. So this one is acrylane or acrylaldehyde. So in first step, what happened? Glycerol reacts with concentrated sulfuric acid, dehydration takes place, and we get acrylane or acrylaldehyde with elimination of two molecules of water. In step second, addition of aniline to acrolein to form beta phenyl aminopropanol takes place, and this addition is known as Michael addition. So this is the structure of aniline benzene ring with NH2. Here, this lone pairs on aniline attacks on the CH2 carbon of acrolein, that is olefinic CH2 of acrolein, and bond shifting takes place, which gives rise to formation of NC bond and oxyanion. Here, this is the structure of that adduct, which is formed by Michael addition of aniline and acrylaldehyde or acrolein. This adduct readily converts into beta phenyl aminopropanol as this hydrogen is removed as H plus and this nitrogen get neutralized. This H plus will go with O minus and we will get OH. And this adduct now will be known as beta phenyl aminopropanol. This is actually enol and keto enol type automerism takes place, and here we get this beta phenyl amino propanol aldehyde. Here we will not get keto in this tautomerism, so it is known as keto enol type tautomerism. It is not keto enol tautomerism. So here reaction takes place as like this. So suppose this is OH. What happen? This bond will shift here. This bond now this bond will gives rise to C minus. And what happen? This H plus which has been removed attach with C minus and we will get CH2. So conversion of OH to C double bond O and CH to CH2. This conversion is tautomerization, and ketoenol type of tautomerization. So beta phenyl aminopropanol converts into beta phenyl aminopropanol, and this is going on. In step third, what happened? Beta phenyl aminopropanol, that is alcohol, undergoes cyclodehydration to form dihydroquinone. And what is this cyclodehydration? Dehydration, that is removal of H2O to cyclize the compound or to form cycle of the atoms. And here what happened? One hydrogen from this ring in this OH will eliminate to give rise to six-membered cyclic ring, and we get 1,2-dihydroquinoline. Why it is known as 1,2-dihydro? Because only 1 and 2 positions are hydrogenated, otherwise it is quinoline. So here one hydrogen is extra and here one hydrogen is extra. If these two hydrogens are removed, if they are not there, then it is quinoline. So it is known as 1,2-dihydroquinoline, as if quinoline is hydrogenated at 1 and 2 position, we will get this compound. So the name is 1,2-dihydroquinoline. In step fourth, what happened? This 1,2-dihydroquinoline on oxidation in presence of oxidizing agent nitrobenzene gives quinoline, and this reaction takes place in presence of FeSO4 or ferrous sulfate. This is quinoline. What is nitrobenzene doing? Nitrobenzene is acting as oxidizing agent, and it removes this hydrogen and hydrogen from this carbon, and there is formation of double bond between nitrogen and this carbon. So this newly formed double bond will convert this 1,2-dihydroquinoline into quinoline, and there is conversion of this nitrobenzene into aniline. In general, the Skraup synthesis is carried out with primary aromatic amines having at least one vacant ortho position. As if suppose this is the structure of aniline, at least this one or this one. These are the two ortho positions, and at least one ortho position must have hydrogen, or they must have vacant ortho positions. If they are blocked by another ring fusions, then this scrap synthesis is not possible in that case. So, this is the synthetic method popularly known as scrap synthesis. Now, let us see the physical properties of quinoline. So first one, it is colorless, hygroscopic liquid having boiling point 238 degrees Celsius. It is sparingly soluble in water near about 0.7%. It is miscible in alcohol and ether. That means it is 100% soluble in organic solvents such as ether, alcohol. It has unpleasant odor, disagreeable odor resembling that of pyridine. It has smell like pyridine and it is very unpleasant. It is steam volatile liquid. On exposure to air, it develops yellow color. So these are the physical properties of quinoline. Thank you.